Some key elements to your label are the actual name of the product, commercial liquid bleach here, as well as maybe the name that the supplier uses, such as Clorox, and then the chemical identifier, NaClO, and there's the rest of that solution containing 3 to 8% sodium hypochlorite and 0.01 to 0.05% sodium hydroxide. And so this is important, this proper name, when we look it up on the hazardous materials table, if there are other bleaches, which you know there are. And then we have our pictograms, our signal words, our hazard statement, which is hazard statement H302, and I'll show you another part of the standard where the hazard statements are listed, as well as the precautionary statement P102, keep out of reach. And so that's where these codes are coming in that we talked about earlier. The health codes, which would begin with 3, the environmental hazards, which begin with 4, and the physical hazards, which are 2 codes. And that's how the global harmonization system is organized. All right, let's take a look inside the global harmonization system one more time. So this product, Clorox commercial liquid bleach, has a hazard statement H302. And if we go to, here we go, H302, harmful if swallowed. It needs to have the label word that's warning, not danger. The UN placard for toxicity is not required for that one, harmful if swallowed, but you will have both oral, dermal, or inhalation, and this one is oral. See, harmful if swallowed, dermal, harmful if contact with skin, and inhalation. You can just barely see it. Oops. So that's inside, again, the purple book, the global harmonization system. And now you see, hopefully, how all these different elements come together, and that creates that standardization. So for transportation, Department of Transportation, they use placards, and these are placards. But for the global harmonization system, they use pictograms. Pictograms are always black on a white background with a red triangle, where DOT has different colors, so you're able to see them at a distance. Okay, these are not global harmonization system. These are Department of Transportation for transporting. They go on the back of vehicles. Now they also sometimes accompany a label, but there may not necessarily be mandatory that they do. But try to memorize these. And 1 is explosives, 2 is flammable gases, 3 is flammable liquids, 4 is flammable solids, 5 are oxidizers, 6 inhalation hazards, 7 radioactive, 8 corrosives, 9 miscellaneous. It just makes hazard identification that much easier. So these are our Ghs pictograms, and remember they're in 3 different H codes. H code 3 is for health hazards, 4 is environmental, and 2 is for the physical hazards. So you can see the health hazard here, health hazard, physical hazards, and then our 1 environmental hazard, physical hazard, and that one's a warning. So a flame, and this one is probably one of the most important ones, because the flash point and the flash point, as well as the boiling point, puts that flammable liquid in a certain category. And of course, the lower the flash point, the more dangerous the flammable liquid, because it's more volatile, right? So the higher the vapor pressure, the lower the boiling point, the more volatile it is. And this stuff is really, really important. And if you start to look at tools for the trade, even though I cover it, this part of the book is absolutely fantastic, because it'll help you get your head around these different elements, chemicals, and how they fit into different categories. So our first one's flammables. And for GHS, it's a little different. Liquids, solids, or aerosols can be flammables. So flammables, pyrophorics, self-heating, emits flammable gas, self-reactive, or organic peroxides. These all fall within this category. This has a higher flash point, combustible. We don't use this term anymore. This has a much lower flash point. Now here, again, the propellant burns. Dispersed and adequate quantity, plus the spark. I don't know. I'd probably be wearing gloves. Does that mean my hair is flammable? Or my hands?
Flammable liquid like alcohol. When it burns, what's actually burning? Is the liquid burning? Does the liquid burn?
Not really.
What burns?
The oxygen inside of it.
The fumes, right? So it's actually the fumes because alcohol is something that evaporates fairly quickly. So as it evaporates, it's changing from what to what? What's happening when something's evaporating?
It changes to gas.
Yeah, it changes from a liquid to a gas, right? So it's actually the gas, the vapors that come off that are burning. Which goes to say that the faster we can make it evaporate, the better it would burn. Can we agree with that?
Yes, sir.
Okay, let's see if that's true.
So the next category is health hazard, and that's the exclamation point. The substance can irritate the eyes or cause skin irritation, inflammation, or dermatitis. So it's a mild health hazard as opposed to a serious health hazard where you're looking at things like acute toxicity, serious eye damage, respiratory and skin sensitization, carcinogenity, reproductive toxicology. So the next symbol is the compressed gas symbol, and it means gas under pressure, and it could be liquefied, refrigerated, or dissolved gas. And so you have to remember that there's 4 different types of gases that can be shipped, or not really 4 different types of gases, that wouldn't be right, but 4 different ways, different physical properties that the gases can have. And one of them is just a compressed gas. So you take breathing air and you compress it and you put it on a scuba diver, or hydrogen. Then you can liquefy it, so it's compressed so much and the temperature is usually cooled, and then that allows the gas to be in a liquid form, and you can get more of a liquid into a jar than you can a gas. And then you can have a refrigerated liquid, which means that it's compressed, and it's the cold air that's keeping it compressed, unlike liquefied propane, where you don't need to control the temperature as long as you hold it under pressure. And then you have something like a dissolved gas, where acetylene is dissolved in other gases. And so there's 4 different ways, right? So we got our pure gas, our liquefied gas, our refrigerated gas, and our dissolved gas. And I really liked the University of Nebraska, the way they broke this one down with their where they explain the different kinds of gases, as well as tell you the H codes associated with them and some hazards. And this is something you guys are going to actually do. You're going to create this hazard map, chemical hazard map. So again, we have our compressed gases. That's like the pure gas is compressed. A liquefied gas, refrigerated gas, so it has to be kept cold, unlike a liquefied gas, which is just under pressure, and then a dissolved gas. There are lots of gases out there. Gases, corrosives, flammable liquids, they're the ones we see the most. So corrosives, something you really got to think about what a corrosive is. First, whether it's an acid and whether it's a base. Because first aid is not typically the same with an acid as it is with a base. And there's certain chemical agents that you use for burns, or not for burns, that you use so that somebody will not get burned if they are unfortunate enough to be splashed. And we're going to talk about that later, but one mistake that people make is they'll wash for 15 minutes, but they won't actually remove the clothing, and that can still cause the burn to continue into the skin. I always say that acids, they burn, and bases, they melt.
We're going to look at the reaction of sulfuric acid and a wet sponge. Safety first. Put on some protective gloves, and after that, we strap on some goggles to our face. Now that we're protected, it's time to put the sponge under some water. After that, I'll add it to its final resting place in a ceramic bowl. And of course, fumes are awful, so I'm taking the whole thing outside for good ventilation. And now comes the fun part. I'll unscrew my bottle of sulfuric acid and slowly pour it over the wet sponge. The sulfuric acid eats through the sponge with the fury of 1,000 suns. Let's check it again and fast forward. And if I run the clip back and forth a few times, you can really see what's going on. Mixing it around nearly depletes the sponge, but why does this happen? Let me know in the comments what you think, and make sure you subscribe for more 1 Minute Science.
So now we have our explosives, which the picture is an exploding bomb, but you can see that they put organic peroxides and self-reacting agents together. And the container holds a potentially unstable explosive liquid or solid. And so unstable or self-reactive substances are chemicals which have the potential to vigorously polymerize, decompose, condense, or become self-reactive under conditions of shock, pressure, temperature, light, or contact with another material. Major types of highly reactive chemicals are explosive, peroxide, water reactive agents, and explosives. So once we get into this category, we're definitely looking at a different page in our response book, because these ones can not only, it could be the percussion, or it could have some kind of projectile associated with it, or it could give off a toxic gas. Not used all that much, more so in the mining industry, but also in heavy construction we would use explosives. So then our oxidizing agents, could be either a gas, liquid, or solid, and then that's how you see the difference between Department of Transportation and the Global Harmonization System. And so they put things in different categories, and it's because the risks of mass transport are different than the risks of somebody using a chemical in the workplace. Oops, sorry about that. So our oxidizing agents, they promote combustion at room temperature with just a little bit of heating. And this class always includes peroxides, chlorates, perchlorates, and nitrates. And strong oxidizers can
Jordan here, and today we're talking about oxygen. There's so much to cover with oxygen, so I'm going to break it up into a lot of different videos. This one covers oxygen's importance as an oxidizing agent or an oxidizer. So, in a chemical reaction, oftentimes you have a species that is reduced and it oxidizes the other species. Oxygen is very good at this. Why is it so good? Well, first, its electronegativity is very high, second only to fluorine. Furthermore, unlike the halogens, which are also very good oxidizing agents, diatomic oxygen is stable enough to be found in pure form in our atmosphere. Furthermore, oxygen is very, very common. In the universe, it is the third most abundant element. In the atmosphere, it is the second most abundant gas. It's the most abundant element in Earth's crust, and by far the most abundant in the human body. So, with oxygen's high electronegativity, high electron affinity, stability, and abundance, it is what we commonly think of when we think of oxidizing agents. In fact, oxidizing agents were named after oxygen. Thank you.
Okay, I hope you enjoy the little videos. It's nice to have a change of pace. So we're moving on to environmental hazards, and Canada uses this far more than we do in the United States. They use it on their Department of Transportation placards as well. But this means that the contents could be an acute or chronic hazard to the environment. So something like PCBs, which bioaccumulate in the food chain, that would have the potential to, of course, cause chronic problems in the environment. And if you were listening to, or if you read the article on Silent Spring, you'll know that it was that DDT that built up in the environment. So the next one is toxic. Toxic is used when the contents are swallowed, breathed in, or absorbed through the skin, and it causes a toxicity. And this is different than a severe health hazard where you look at more of respiratory effects or sensitizing effects.
Derailment that sent hazardous chemicals, a gas called vinyl chloride, spewing into the air. More than 70 people sought medical treatment for burning eyes, labored breathing. And ABC's Lindsay Davis is on the scene.
Thousands of gallons of the hazardous chemical vinyl chloride spewed into the air from the ruptured car. Residents were told to stay in their homes. 3 schools within a mile ordered to keep students indoors.
We are saying to all that are watching this, that live within the borough of Paulsboro, that it is a time for caution.
71 people were admitted to a local hospital. Vinyl chloride is a colorless gas. Inhaling it can cause dizziness, headaches, and drowsiness. Breathing very high levels can cause loss of consciousness, and extremely high levels can even cause death.
There have been concerns about this bridge before.
I've been told today that the residents most close.
And we're going to talk about a little bit later in class, emergency response, the incident command system. And this is where, if you kind of think all together about SARA Title III, community right to know, well, the community had the right to know what was being transported over their bridge. So a couple of final words about the H codes. As the number gets higher, the hazard gets decreased. So as the number is lower, the hazard is higher. So you could see for flammable liquids, H code H224 is extremely flammable liquid or vapor, where an H code 6 is combustible. Combustible would be less hazardous than extremely flammable. And this is completely opposite of the National Fire Protection Agency. With them, the higher the number, the more dangerous it is. And so you just have to pay attention, I guess, is the best way to say it. It's too bad they weren't similar. So the safety data sheet is a comprehensive document that's used in the workplace. Employers have the responsibility to provide it to their employees, as well as sharing that through Title 3 if they happen to have any emissions. And so primarily the global harmonization system is for the workplace. Department of Transportation is for transporting things on our roads, airs, waterways, and National Fire Protection Agency is for our stationary bulk storage containers. And we're going to cover that in our next module. Okay, so what does this tell us? Can you think of anything already? Do you know what this one is? It's an oxidizer. No, it's not. It's something flammable, maybe a flammable liquid. Here's our warning sign, right? This means that there's danger and there's a health hazard. So let's see what it is. It's gasoline. And so I really like this document that is available on OSHA.gov. And it's just a brief, but it talks about the labeling and the pictograms, and it provides additional information as well as explanations of the precautionary statements, the signal words. And although we already went through it, it's kind of a nice little reference when you're looking up things for the global harmonization system that maybe you weren't familiar with. It also gives you an example of what a label should look like and examples, so that if you looked it up from the H codes, you'd be certain that your SDSs were developed appropriately. So SDSs are as good as the manufacturer who makes them.